All right, good afternoon, everyone. So today is March 8th, 2023. We are going to continue our discussion on objects and classes on object-oriented programming, kind of a brief introduction to object-oriented programming. In my first class today, the students said that there was something issue with my internet connection, that it was quite slow, and they said that turning off the camera helped speed that up, helped me be more understandable. Please, if that is the case, if you are seeing that there's a lot of let me write that into the chat actually, but if there's a lot of delay, let me know. I'll turn the camera off. Don't ask me to turn the camera off if you just don't want to see me, okay? Because that would sound bad, but just let me know if it's better. Okay, glad to hear that. Maybe it's a time of day thing. I don't know. All right. All right. So again, I'll come back and check the chat every once in a while. If there's a problem, let me know. All right. So Kadir, you were in my last lecture, so you'll have a good frame of reference. Let's get on into objects and classes. But first, quote of the day, Sherlock Holmes tells us, written by Sir Arthur Conan Doyle. This is the same quote as my earlier lecture. I'll try not to do that as often. I'll try to have different quotes, especially since many of you are in both classes. But once you eliminate the impossible, whatever remains, no matter how improbable, must be the truth. And so, yeah, so figure out what's not possible, get that out of the explanation, and whatever remains, even if it seems like that can't be right, that just doesn't seem right, it must be at least the truth if it falls into that category. So sometimes not things that seem reasonable are always the truth. All right, okay. Where did we leave off? All right, we left off here in the example where I showed you guys that this would result in a compiler error, whereas local variables are class variables of if we had what's that? Okay, where class variables did not have this problem, did not have a compiler error because they were given default values. Okay, so if we skip back here, right? A class variable, one more here, class variable gets a default value, whereas a local variable inside of a method does not. So this would give us a compiler error. The other one did not give us a compiler error. Okay. Okay. Some other differences between variables of different types. A primitive type is simply a storage space in memory that has a value. Okay, so a primitive type like an integer, int I equals 1, just stores in memory that value of 1. Okay, an object type, on the other hand, has a reference to an object. This is very similar if you remember the discussion on arrays from last semester. Same thing. So what happened when we said array A equals array B, right? So what happened when we said, so example, primitive type, object assignment I equals J. It takes the value in J and places it in I. So if I were to then after this, if I were then to say J equals 3, right? This would not change the value of I, right? This would not change the value of I. I would still have that same old value of 2. However, here, right? C1 points to a circle. C2 points to another circle. If I say C1 equals C2, it takes the reference that C1 is pointing to and makes C1 point to the same reference, the same circle object. Again, if you remember from last semester, the arrays discussion, It does the same thing with arrays. It didn't copy a new array that had the same values. This right here does not create a new circle that has the same radius. It makes C1 point to the same circle as C2. Okay. So, because sometimes this old circle C1 over here, this old circle over here, does not have a reference to it, it doesn't have anything pointing to it, it's what we might call garbage or trash, or in Turkish çöp, right? So nothing points to it, we can't get to it, there's nothing we can do. It might as well not even exist. Okay, so this is going to bring into the discussion, I'm sure many of you have heard, and I think I talked about it in 101, the old idea that, have you tried, if your computer isn't working, have you tried turning it off and back on again, right? And the reason why that's funny is because I'm sure many of you have had that solution before. Just turn the phone off, turn the computer off, whatever. And the reason for that is these objects, they're stored in memory. They're not stored in the hard drive, right? They're not stored in the data. They're stored in the memory, the RAM, okay? And as that RAM fills up, it becomes harder and harder to find places to put new objects that we're creating. So things like this, objects that we no longer use, we don't have anything pointing at it, it might as well not even exist, take up space in our RAM, right? Take up space in our RAM and slow down our programs. Which is why Java does this really neat thing called garbage collection. So when the Java Virtual Machine, the JVM, when it notices that certain objects, certain memory locations are no longer used and won't be used and can't be used, right? Because that circle that was being pointed at, that no longer is pointed at, it can't be accessed anymore. The program can't get to it anymore. So it might as well not even be there. So when it senses that that is going on, it collects that memory space and allows it to be used for other programs or for other objects, new objects that get created. Okay, that helps speed up the program. Okay. Tip. So to help the garbage collection, if you assign a null value to the object, to a reference, then the JVM will automatically collect the space, even though it doesn't know. Because again, it will only do this once it realizes that nothing is pointing to that object in memory anymore. So as long as that reference variable continues to point to that object, then it won't collect it, because it'll say, oh, there's still something pointing there. It still can use it. It's only once the JVM realizes that an object cannot be used anymore that it will collect it through garbage collection. There's no requirement to do this, and I would say for the level and size of programs that you guys will be creating, there's really not much need to do this, but it is something that can be helpful for larger programs that you might create for companies in the future. Okay. I'm going to skip over because I don't want to spend too much time on this set of slides. But the date class here, so this is a UML class diagram, right, showing some of the useful methods, right? One thing this does point out that I do want to point out to you as well is that the plus sign on a method or attribute in a UML class object or in a UML class diagram represents public. This is a public method. It can be used by anyone using this class. The minus sign represents a private attribute or method. And we'll talk about when you want to use private, when you want to use public later. Okay. But I do want to go ahead and point that out. Okay. But this shows some examples of the date class. The random class, also we used this last semester, right? There's math.random. There's also the random class that gives us more options as far as how to do random things. So a random integer, a random nextant that has a value between 0 and n exclusive. This next double, right, is the same as what math.random, right? Okay, so we used math.random before, but the random class is also an option that you can use. So some ways that we can do that. Right, hopefully you guys realize that this is a lot easier than the way that we figured out a random number between 0 and n. Question. Java system dot system.gc. No, you don't need to do that. It should do it automatically. For garbage collection. He's asking about for garbage collection. Okay. Okay. Okay, so what we will use is we'll use the term instance. I will also sometimes call them class variables. Okay. So an instance is an object of a class. Okay. So instance is a special word. You'll want to learn that word because of what we'll call the instance of operator when we start talking about inheritance. Okay, but instances are an object of a class. Okay, and so instance variables or class variables belong to that specific instance. So radius from our circle example is an instance variable. It's inside of the instance. It's inside of it's a class variable. It's not inside of a specific method. It can be used inside of the methods, but it's not a variable that only exists inside of that method. Okay. Some of you may have heard terms like global variables. An instance variable is like a global variable, but it's like a global variable for a class. But it only exists inside of a class. Okay. Static variables are shared by all the instances. Static methods. This is where it's more important to know what the static keyword does. Static methods are not tied to a specific object, meaning just like we talked about where you created public static methods last semester, you could use them without creating an object of that type. Non-static methods, you have to create an object of that type to use that method. Okay. Static constants are final variables, so we'll use the static modifier for a constant, a value that does not change. Okay, we talked a little bit about constants last semester as well, and they're shared by all the instances of the class. So we'll see some examples of that, I think, in the next set of slides. Okay. Use the static modifier to declare variables, constants, and methods as static. So we did that last semester, but with methods, we will also see how to do that with constants and variables. Okay, so for an example here, we see we have this underlined thing means static. Okay, so here we see underlined static variables or methods. So the underlined integer variable number of objects is static, meaning that all instances of the class share that same variable. All objects of the circle class type share that variable. Get number of objects is static, so that means that I can use that method whether I have an object created or not. Okay. So here we instantiate or we create an object of that type. So we create a circle 1 with a radius of 1. We create a circle 2 with a radius of 5. The number of objects, because we're able to change that value, becomes 2. And I'll show you how that works in an example. What we'll do is we'll do some examples in the second hour to show how this works. Okay. Notice that for this particular circle, the only thing that's stored in memory for this particular circle is the radius value. Same thing with this one. Everything else, the number of objects, is a shared instance variable that's stored outside of this specific object. The static get number of objects is a method that's shared between the two and exists even without the circle type. The get area method is something that exists, but it's not different from each of them, and so therefore when we call this method, it's based on the radius value. All right. We'll show this, the circle with static members. We'll show that in a moment. Okay. So some visibility modifiers. Again, last semester I said just type public for all your methods, right? Public, static, return type, method name, right? And I said we'll get into why you type public. Well, now we're getting there. Okay. So visibility tells us who can see a particular method or variable, or a class for that matter. Okay. Now, a public thing can be seen by anyone, right? Any class in any package. Private means it can only be seen by the class that it's in. Okay. Now, why does this become important? Okay. Because, say for example here, okay, we won't talk too much about package stuff. That's a little bit beyond the scope of this class.